Classwork 9 or assignment 9, there's two problems. The first problem is find the actual infiltration rate, okay, from runoff generation from infiltration excess using the Bureau input rainfall. Given the Phillips equation, from this is an infiltration equation. Okay, from this Phillips equation, we assume that t is small t, and we can neglect the kt, the second term, and we substitute t in the equation of the infiltration rate. This is F capital F is mean accumulated infiltration equation, but Ft is the infiltration rate. So we got the equation of F, and we use this for estimate the infiltration capacity. So F star infiltration capacity is depend on the capital F. Is mean if the accumulated infiltration increase, the F star will be decreased. Okay, and given all the parameter for hydroconductivity and sorptivity. Okay, and below is annual hourly rainfall. Okay, for about 10 hours. So in this case, it's that the equation to find is to remind you about this equation is a point process on the surface. And for coming, and this is infiltration. This F star is maximum infiltration, and if no infiltration, the excess infiltration excess is QS. So it means in this equation we say that the infiltration is equal to rainfall if rainfall is less than infiltration capacity, and this infiltration equal to infiltration capacity if the rainfall is greater than infiltration capacity. And at a similar way, that the QS is 0 if rainfall is less than F star, and equal to difference between rainfall and infiltration if the rainfall is greater than F star. Okay, we can apply for example that at the first hour, the capital F is mean no infiltration, so it means this start from 0. Okay, and the next we substitute F in this equation. When we substitute 0 in this equation, we expect that the infiltration capacity is infinity. So if the infiltration capacity infinity is mean FA, so FA it should be, so it is this condition, the rainfall is less than F star, so the FA is equal to rainfall, so FA is equal to 1.85. So this means that this condition, so it means there's no runoff anymore, so QS is 0. Okay, and we do further for the next hour. The accurate infiltration is from the previous hour, so this one is 1.85, and if we substitute 1.85 in this, in for F there is some number that, let's say that it's about okay. So it's still in the first condition, the rainfall is still less than the infiltration capacity, so we expect that infiltration rate is equal to 104 and runoff is 0. Okay, so you can do further for the next hour. So accumulated rainfall, accumulated infiltration now is from the previous 2 hours, so it should be 2F9. So it comes from this accumulate from this to get to 0.89. Okay, so finally we want to know what is the how much of the infiltration excess as how much of FA. So this means at this point the rainfall should be equal to summation of FA plus summation of QS in terms of water balance. Okay, for the next question, determine the runoff from three mechanism from QF. Now, from previous problem we used QS, now we use the QF. It means infiltration excess runoff, QSE, saturation excess runoff, and subsurface runoff. If the depth of the soil is 2.2, the porosity 0.4. Initial saturation is 80%. For the F star, we use the same F star. And for QS is a function of the TC and soil rate. Okay. So this process is we can divide into two processes. The first is the surface process at the surface. The rainfall coming, and this is infiltration FA to the soil, and on the top it can be maybe QF. Okay. So at the soil we can imagine that there is like the storage. Okay. And this storage can store water inside. At the bottom of the soil can release the water we call QS, okay, subsurface runoff. And the size of this the storage capacity is SB. So if sometimes the storage in the soil is the water storage is increased and is above the SB, it can be like this. So we expect that there is a QSE on the top of the soil. Okay, so we can estimate start from the SB. So SB equal to depth of the soil times phi. So it's equal to depth of soil is this 2 millimeter times the porosity. So we expect that the depth of the soil and the storage capacity is 80 millimeter. Okay, and we can start to next step. We have to draw the table to do calculation. Okay, so I have to this one need space for calculation. Can put somewhere here. Okay, we can start from the first the accumulated infiltration is 0. Okay, so and we substitute 0 in the F star equation, so we get like infinity. So the infiltration is equal to the rainfall 15. Okay, there's no runoff. Okay, so we can finish the first part, and for the second part we can do later on. It depends on your plan. Okay, so we can do finish, and this is we do the same as the previous the classwork problems. And for the second part in the soil, ST start from the initial storage. It start from SB is okay, but initial storage is 80%, so it means 80% of 80, so it's 64. And QS is equal to 64 divided by 30. So we expect that is to be 2.13. And for the saturation excess, at the beginning we assume is no saturation excess. And for ST book 3 plus 1 is 3 plus 1 is come from equation of delta S equal to FA, the water balance equation. And in this case, we divide into there's 2 time step. It means it's equal to S storage at the 3 plus 1 time step, and the difference between okay, so it means S3 plus 1 is equal to ST plus FA subtract SE and QSS. Okay. So it means this equal to 64 plus 15. Yes. 64 plus 15 subtract 213 subtract 0, so we got 76.87. Okay, and we can move for the next the storage equal to 76.87. Okay, this one is we can finish with if this ST plus 1 is, for example, okay, so this means is the storage is above the storage capacity, so it's not possible. So you have to keep the maximum, the storage should be 80. So you have to bring the 0.45 to something like this. It's not possible that water can higher than the storage capacity. And finally, we want to know what is the how many percent of the is similar to the example. We want to know how many percent of rainfall go to saturation excess, subsurface, and saturation excess. You can do by yourself for the rest of the problem.